Waste is any unwanted or unused item. The growth in economic activities with the increase of production and consumption has caused the increase of municipal solid waste, which become a global challenge. There are many efforts that have been done to overcome this problem, such as incineration of the waste, dispose the waste at the landfill, and do biological treatment to the waste.
There are many challenges of waste-to-chemical process. The first one is the carbon dioxide emission that come from the combustion of carbon resources that used for heat, electricity, and mobility. The second challenge is the leakage and flammability of toxic chemicals that come from the composition of scrap tires. The third one is the presence of chlorine, bromine, and mercury that come from the printed circuit board. The fourth one is the presence of nitrous oxide in denitrifying phosphorus removal process that can cause a greater impact to our global warming.
The next challenge is lack of enforcement and implication. For example, in Malaysia, municipal solid waste policy and waste to energy is not exposed enough by the industrial people and academic institute. There is a few policy that is related with the solid waste management that has already been put in Malaysia plan, but due to the lack of enforcement and implication, it does not effective. Then, in the process of changing the solid waste into a chemical or energy, it requires a high technology machine and a specific procedure. So, it will be needed a skillful person and knowledgeable to handle the specific procedure. For the example, when treat the waste, it must be separated into organic and inorganic waste, which both of them have a specific procedure. Lastly, the cost will be a challenge when a high technology machine is required in the process. As the example, between gasification and incineration, gasification is 30% more effective than incineration, but the initial cost for the incineration is more lower than the gasification.
Real examples of research and innovation. The first example is recycling of waste automobile tires, which transforming char in oxygen reduction reaction or ORR catalyst for alkaline fuel cells. A new approach for the reuse of a problematic waste such as waste tires. The charge obtained from the pyrolysis, considered to have a little to no economic value, may instead be transformed through a simple heat treatment into highly efficient catalyst for the ORR at virtually no cost and free from precious metals. Second example is homogeneous Lewis acid catalyst for the transformation of hemicellulose and cellulose into variable chemicals, fuels, and nanocellulose. This received the attention of researchers due to its superior characteristics such as high selectivity, ease of handling, least corrosive properties, recyclability, and effectiveness in hydrolyzing the complex structure of lignocellulosic biomass. Studies have been targeted mainly to catalyzing the degradation of hemicellulose for the production of valuable fuels and chemicals while maximizing the cellulose exposure to the subsequent post-treatment such as dilute acid or enzymatic hydrolysis. Secondly, is to promoting the hydrolysis of cellulose into water-soluble reducing sugars, fine chemicals or potential fuels. Finally, enhancing the dilute acid treatment for the cellulose depolymerization reaction for the fabrication of hydrocellulose or nanocellulose from cellulosic feedstock.
So, we proceed to the benefits and importance of the new innovation. The first one is it can increase the employment. For example, it can create the job opportunities to support facilities and construction. For example, environmental monitoring and manufacturing. The second one is no waste chemicals because it uses carbon capture and storage in waste to energy to convert carbon negative. The third one is lower the risk of spreading diseases For example, digester used as fertilizers that helps for growth of agriculture. The fourth one is it can reduce the gas emission by 3 separate mechanisms. The first step is by generating electrical power. The second step is by combustion process, and the third step is recovery ferrous and non-ferrous metals from municipal solid waste. The fifth one is it can reduce the carbon footprint by utilizing and capturing methane gas method that produced by anaerobic digestion. The sixth one is it can be preserve the water quality of the groundwater. For example, wastewater and leachate can be prevented from taking over the groundwater resource through well-organized waste-to-energy system.
As a conclusion, everyone must cooperate to succeed in the effort to transform the waste into chemicals without ignoring the green chemistry principle.